Professor R. Ashokamani, Director, Research and Development, Dhanalakshmi College of Engineering, Tambaram, Chennai. He is former professor and head of the department, Physics, Anna University, Chennai. He is presently guiding 3 research scholars. He has more than 44 years of UG and PG teaching experience and 33 years of research experience. 14 research scholars have obtained doctorate under his guidance in the area of material science and solid state physics. He has more than 150 research publications to his credit, of which 90 are in international journals. He has authored a book on solid state physics, which is an international publication. He has participated in several international conferences, both in India as well as in foreign countries such as USA, UK, France, Germany, Italy, and Yugoslavia. He has been a guest scientist at ICTP, Italy, several times. He is a fellow and treasurer of Tamil Nadu Academy of Sciences.
Welcome to the UGC lecture series in applied electronics. We have been going through a set of lectures on optics, unit 1, and in today's lecture we will be covering a few things which we find in the last lines of the unit, such as the determination of specific rotatory power, half shade polarimeter, and uses of polarized light. Hence, in this last lecture in the series on optics, the contents are specific rotation, Lorentz half shade polarimeter, and applications of polarization. You all know that the ordinary unpolarized light, the vibrations which are made on the ether particles according to Huygens theory, the vibrations will be in all planes. Okay. You have a plane like this and another plane and so on, and so the vibrations will be found in all the planes. The resultant can be had in 2 directions, maybe x and y. This is one of the planes, this is another plane. That is how you represent unpolarized light. Now, this unpolarized light will become plane polarized if it is passed through a crystal like quartz or tourmaline, as we have seen earlier. The ordinary light consists of many beams vibrating in different planes, and that is shown at the top. The plane polarized light consists of only those beams that vibrate in a particular plane. So, this is a polarized light, this is unpolarized light, and this light that you have got here, when it is passed through a nickel prism, gets polarized. This is a plane polarized light. That is how you end up with the production of a plane polarized light from the unpolarized light. If this plane polarized light is passed through an optically active medium, here I show a molecule, it may be a sugar molecule or a turpentine or a solid substance like quartz and so on, and the plane polarized light will undergo a specific rotation. So, the plane is looking like this, the plane polarized light, it undergoes a rotation through an angle alpha or theta when it is passed through an optically active medium, and this optically active medium may be a solid substance or a liquid substance. If it is sugar, the device that leads to this kind of rotation is called saccharimeter. A saccharimeter is one which can be used to measure the optical activity or specific rotatory power. The plane polarized light can be rotated by an optically active material, right, and you have got here the angle by which the polarization, the plane polarized light is rotated, gets rotated through an angle alpha. And you have here the definition of specific rotation. The observed rotation alpha depends upon the number of molecules encountered, and it is proportional to the path length L of the solid substance or liquid substance, and if it is a liquid you have got a concentration C, and therefore, define the specific rotation alpha as alpha is equal to 100 times alpha by C into L. What are C and L? C refers to the concentration of the solution. It may be sugar solution as I told you, or any other solution, even it can be buttermilk or oil. And it is important to note at this point, this study of polarization, optical activity, specific rotation, etc., it is not only of academic interest. As I told you, in one of the earlier lectures, this can be used to check the quality of buttermilk or quality of milk or curd. And so, from the biotechnological point of view, and also from other applications you have got, which I will be dealing with at the end. They have got several applications of polarization. As you know, our cricket players are using the glasses which are polarized glasses. You see them wearing colored glasses to cut the unwanted light, or the glare can be eliminated by using polarized glasses. And so, it has got several applications. You have heard of Polaroid camera and so on. So, it has got several applications. So, what I would like to tell you is, it is not only the academic interest one has with regard to polarization, it has got several other applications in, especially in food technology and many other applications. Okay. When you are driving a car and you want to avoid glare, glaring can be eliminated by applying polarized glasses. Therefore, the specific rotatory power or a specific rotation alpha will be 100 times alpha by C, the concentration multiplied by the length L expressed in decimeters. And the optical rotation obtained by the light passing through the solutions, the polarimeter that you are talking about, which is used to determine the alpha that you are talking about here, you use a polarimeter. The polarimeter consists of a glass tube and an analyzer is a nickel prism. A polarizer is again a nickel prism. Which one comes first? A polarizer comes first. You have got a unpolarized light, you have got a polarizer, right? You have got an unpolarized light. What is the function of polarizer? The unpolarized light is made to become plane polarized when it is passed through a polarizer. That is the reason it is called polarizer. A polarizer, what it does is, the unpolarized light is made to become plane polarized, and then it is passed through an optically active substance, which rotates the plane of polarization by an angle theta, and then you analyze what you observe by what is called an analyzer, that is again another nickel prism. Okay. Then a half shade plate, you are using a half shade plate. Light from a monochromatic source passes through a nickel prism N 1, that is your polarizer. Then through a half shade plate, the solution, and again through a second nickel prism N 2, which is used as an analyzer. N 1 is the polarizer and N 2 is the analyzer, and finally, it reaches the telescope. The angle through which the plane polarized light has been rotated can be measured by means of a telescope, which has a calibrated scale. That is what you do using a polarimeter. So, I show visual of a polarimeter. As I told you here, you have got a light source. The light source that you have got here is a unpolarized light, and this unpolarized light figuratively, as I told you, is represented like this, wherein you have vibrations in all directions, and this unpolarized light can be made to become a plane polarized light by making it to pass through what is called a polarizer. So, you got a polarizer here, vibrations you got in all planes. Now, it is all the vibrations are cut off either excepting this vibration. You see here vibration only in a particular direction or in 2 dimensions in a particular plane. Here the unpolarized light will be beam vibrating in this plane, another plane there will be vibrations, another plane, and so this is unpolarized light. But here all the vibrations are cut off, excepting the fact that the light will be confined only to a particular plane. This is a plane polarized light. It is called a plane of polarization, the plane polarized light. This plane polarized light, when it is made to pass through the sample tube, which contains maybe sugar solution, then what happens is this light beam undergoes rotation through an angle alpha, that is being analyzed by a analyzer. This sample tube is kept the sugar solution or a solid substance, which we call as a optically active medium, is capable of rotating the plane polarized light through an angle alpha. This is called optical activity, and it can be viewed by a telescope or by eye. And how do you measure the angle alpha? The working principle of a polarimeter: rotate the analyzer such that the view is completely dark. So, you rotate the analyzer, this is analyzer, right, analyzer, you rotate it so that in the field of view of the telescope there is complete darkness. Fill the tube with the solution. When you fill the tube with the solution, again when you see what you observe now, now the field of view becomes bright. Previously it was dark, it was completely dark, then it becomes bright, then rotate the polarizer again to get complete darkness. Measure the angle through which the analyzer has been rotated to obtain complete darkness, that is the angle alpha, that should be substituted in the expression that I showed you earlier to obtain what is called a specific rotation. The alpha, the specific rotation, this is angle alpha. What is angle alpha? Angle alpha is the angle through which the analyzer is rotated to obtain complete darkness in the field of view. When you observe, you should have complete darkness as you had earlier. Before the medium is filled with some liquid, you had complete darkness. When you have the liquid medium in the tube, you get brightness. To annul the brightness, you rotate the analyzer through an angle alpha. That angle alpha should be substituted here. Then, knowing the concentration of the solution and the length of the tube through which light is passing, those things are to be substituted to obtain this alpha, capital alpha here, that is called a specific rotation. For the medium that you are talking about, this alpha can be obtained using the polarimeter. Now, what is the problem when you are using a polarimeter, a normal polarimeter? The problem is following: determination of the exact position of N2, which gives complete darkness, is a difficult problem. Determination of the exact position of N2, that is the second nickel prism, which the or the polarizer. The first nickel prism is a polarizer, the second nickel prism N2 is a analyzer. You rotate the analyzer, which gives complete darkness. How will you say complete darkness? Now, that the definition of complete darkness is somewhat difficult. Therefore, the solution to the problem is use a Lorentz half shade polarimeter. Now, let me tell you what is meant by a half shade polarimeter or a half wave plate. And this plate that you have here, which is made up of quartz, is a half wave plate. Why is it called a half wave plate? Because it is capable of introducing a path difference of lambda by 2. What a wave is having a wavelength lambda. What is a half wave? Wavelength divided by 2. Lambda by 2 is called a half wave. So, a half wave plate is capable of producing a path difference of lambda by 2 or a phase difference of pi. A path difference of lambda by 2, by now you know it corresponds to a phase difference of pi or pi radians or 180 degrees. So, a half shade plate that you have got here compared to glass, you have got a glass here. Plane polarized light is passing through glass as well as quartz. You have got a plate right. The plate is here through which the plane polarized light is passing. The plate is made up of two parts. The plate, the circular plate, half of it is made up of quartz, which will lead to double refraction. You know by now a quartz plate will lead to double refraction. What do you mean by double refraction? A light passing through a quartz plate, double refraction means for every light ray there will be two refracted rays. We have seen earlier the O ray and the E ray. What is O ray? O ray is the ordinary ray which obeys the Snell's laws of refraction, whereas the E ray is called an extraordinary ray. In a short while I will show once again what is the double refraction, but the point is a quartz plate is capable of producing double refraction, that is what we will be getting now, double refraction, and what a glass plate, which of course will not show anything, right. So, this is a light ray. OP refers to the polarized light passing through glass. I would like to tell you again, OP is the path taken by the plane polarized light when it is passing through glass. Okay. Then the light ray which is passing through the quartz plate will undergo double refraction, is a phenomenon in which you see the light ray is passing through nickel prism. A nickel prism will give rise to double refraction. You have the what is E? E is the extraordinary ray and O is the ordinary ray. A light ray which is passing through a nickel prism will undergo double refraction. What is the double refraction? For ordinary light ray which is passing through glass, on every ray of light there will be one refracted ray, but here for every ray of light that is passing through the nickel prism there will be two refracted rays. You see here when it enters here, there is one light ray coming here, that is called the ordinary ray, that is another light ray coming here, it is called the extraordinary ray, right. The ordinary ray, it obeys the laws of refraction. The extraordinary ray will not obey the Snell's laws of refraction, that is extraordinary, this is ordinary. Okay. So, for every light ray there will be two refracted rays, that is called double refraction, that is experienced by the light ray which is passing through the quartz crystal. One half of the light beam will be passing through glass, that will have the plane of polarization in this direction OP. Okay. Whereas, the other half of the light beam which is passing through quartz will be split up into, because quartz is a material which will produce double refraction, that will lead to ordinary ray and extraordinaries. So, the resultant between the ordinary and extraordinary will be along OQ. The point I want to make is the light ray which is passing through glass will have its plane of polarization will be along OP. Okay. Whereas, the plane of polarization of light which is coming out of quartz after passing through the half wave plate will be in the direction OQ. So, the resultant thing will be what a half shade plate or a Lorentz half shade polarimeter does is it leads to an angle 2 theta, theta plus theta, that is 2 theta, that is a rotation will be through 2 theta, right. The angular separation between OP and OQ. What is OP? OP is the plane polarized light which is passing through the glass. OQ is the plane of polarization of the light which is passing through the quartz crystal. Now, the angular separation between these two will be equal to 2 theta. Okay. The half wave plate turns the plane of polarization by 2 theta, that is the important point. The resultant plane of vibration of light will be along OQ, that is what I showed you here OQ, and this is the light ray passing through glass, this is the light ray passing through the resultant that you get when light ray passes through quartz crystal and so on. The angular separation will be 2 theta. To find a specific rotation of a solution, the analyzer is rotated such that the two halves of the light seen through the telescope will become equally dark when the tube is rotated without the solution and then with the solution. the two halves will be equally dark or equally bright. So, you have to rotate the analyzer, so that the two halves will be equally bright or equally dark without the solution, and then when you have the solution, through what angle again the analyzer should be rotated in order that the two halves are equally bright or equally dark. That is your angle alpha. Okay. That is what you obtain from the Lorentz off-state polarimeter. So, it is used to measure the angle of rotation of optically active substance in the solution. Angle through which the plane of the polarized light is rotated on passing through a specific length of solution of known concentration. The concentration is C and L is the length, and then you make use of the formula that I showed earlier to get the capital alpha. So, the experimental arrangement is shown in the figure which follows this slide. S is a source of monochromatic light. Okay. Then you have got a lens here through which light is passed, and then this is the nickel prism N1, this is a half shade plate, the solution, there is a tube through which the light is passed, it contains the solution, P is the polarizer, A is the analyzer, everything is seen through a telescope. That is the one that I showed earlier also. And so, the S is a source of light, a monochromatic light is placed and you have got a convex lens. The beam is rendered parallel after passing through the polarizer P, the light becomes plane polarized. The plane polarized light will be rotated by an angle alpha when it is passed through a solution, and then you know what you have to do. You have to rotate the analyzer, so that you get equal darkness or a equal brightness. So, the polarized light beam causes a, you got a half shade device, Lorentz plate, and then a tube T containing optically active solution. The transmitted light passes through another nickel prism A, which can be rotated about the direction of propagation of light as axis, and its rotation can be read on a circular scale that gives the angle alpha. The polarizing filter has two applications in both color photography and black and white, and it got several applications. Before I come to applications, by now you should have understood how the specific rotation alpha can be obtained. Now, having said, now we will pass on to the applications of polarized light. A polarizing filter is one which can be used in photography. The polarizing filter has two applications in both color photography and in black and white. It reduces reflection from some surfaces and it can darken the sky. This absorption allows glare reflected from, for example, a body of water on a road to be much reduced. You have got water drops or ice, and that light which is incident on these media, the reflected light, as I told you much earlier. How do you produce polarized light? Polarization can be produced by reflection also. The reflected light will be polarized. If the reflected light is polarized to a large extent, it will lead to glaring. So, in order to avoid glaring, you have to use a filter and so on. So, reflections from shiny surfaces, vegetation, sweetie skin, water surfaces, glass, they will lead to a sort of glaring, and the glaring clarity will be lost. And so, the clarity can be improved by using a polarizing filter. This allows the natural color and details below the surface can be seen. Reflections from a window into a dark interior can be much reduced, allowing it to be seen through. I am showing them the slides later. The same effects are available for vision by using polarizing sunglasses. Let me now show some other applications figuratively. This is what you see now. Without using a polarizing lens or a polarizing glass, you have the scenery is looking like this. The contrast is not very good. Now, you see here with polarizer, a polarizer filters out the polarized component of light from the sky in a color photograph, increasing the contrast with the clouds. You have got the contrast is very good now. You see the difference between this figure, the left hand side, that you obtain without polarizer, the right hand side with polarizer, the contrast gets improved because you are cutting off the unwanted polarized light. So, now again you see insert here without polarizer and with polarizer, a glass squid photograph without and with a polarizing filter, the clarity will be better, and here again you have with polarizer and without polarizer. Now, the polarizer rotated to pass polarized light the bottom and rotated by 90 degree to block it, suppressing reflections and making it possible to see through the window top. The seeing through the window top, the clarity is improved. Now, you see this is a better picture. What you observe now as a application, the vegetation, you look at the plants, you look at the right side, in which picture the clarity is better. The clarity on the left hand side, the clarity is better. You see the leaves and all these things clearly seen with a polarizer, but without polarizer you see the clarity is much poorer. So, polarizers are often used to improve the appearance of vegetation. You see the left hand side is the picture that you get on the left hand side with polarizer, it is having better clarity. Here again you see two the things which are using often all the students are using. One is with polarizer, the other one is without polarizer. Now, which one is better? Effect of polarizer on light reflected from a surface. You got a surface here, you see the numbers can be read here. You see the numbers 1, 6, 1, 0, 2, the numbers can be read. Then again the surface beneath water medium, right, the surface can be clearly seen with polarizer, whereas the surface is diffused without polarizer. Effect of polarizer on light reflected from a water body, from a water surface, the see the clarity is much better with polarizer. And see again the application of polarization, you see here you got a automobile, are you able to see them what is inside the automobile, the clarity in which picture the clarity is better. You see the seat here, the seats can be clearly seen when you use a polarizer, seating arrangements, and you got your all these things can be clearly seen, and here is foggy without polarizer, and you can have a perfect catch again using the sunglasses, wherein again polarization becomes a very important the concept put into practice. Let me now summarize the last lecture that I delivered today in the first unit. Optically active substances are those which can rotate the plane of polarization. A half wave plate will introduce a phase difference of 180 degree between the O and E rays, that is ordinary and extraordinary rays. Introduction of half wave plate will lead to a rotation of plane of polarization by 2 theta. Glare of light can be removed using polarizers. Let me now pass on to the following questions. What is meant by specific rotation? Question number 2, what is meant by a half wave plate? What for Lorentz half shade polarimeter is used? Lastly, mention some of the applications of polarization. With this we come to the end of the lecture number 22 that covers the portion intended to be done on optics. Thank you.